Joining me. My name is Skerrett. I work with the Eclipse Foundation. How many people have heard of Eclipse here? So most people. How many people know of Eclipse as being an IDE, specifically a Java IDE? Okay, so one of the things to remember when we go through this presentation is most of the stuff I'm going to be talking about has nothing to do with Java IDE. We're talking about projects for developing IoT applications, so frameworks and runtimes for developing IoT applications. And so a lot of people think of kind of Eclipse and they equate Java IDE, but so that's sometimes I want to kind of open people's eyes that Eclipse is actually much bigger than just the Java IDE. So to kick it off, I'm not going to spend, I kind of think the previous presenter and everyone knows that IoT is going to be big, and kind of everyone should have a hockey stick chart in your presentation when you're starting in an industry. But IoT is going to be big. But I think kind of more, hopefully not too controversial, is that I would stipulate that if IoT is going to be that big, it's going to be open. It has to be open. That kind of the open versus proprietary, you're not going to get kind of the scale, the adoption of proprietary technology to the scale that we need to make IoT as big as it is. So kind of the statement here is that it needs to be open. And if IoT is going to be big, if IoT is going to win, it has to be open. And I think there's lots of examples to back up this statement. You can kind of look to the history of the internet. How many people here believe that if kind of Tim Berners-Lee said, you know what, I've got all these cool inventions, I'm going to patent them, I'm going to kind of move to Silicon Valley, to create a VC-funded startup and try and monetize and create a company based on the World Wide Web, and I'll call it World Wide Web. If he had done that, would we have gotten to the internet that we have today? Right? And because at the time there was lots of very valid options to kind of a more open internet with CompuServe and AOL. So I think based on that, right? So essentially the internet today is run on the principles of openness. So be it the open standards or open source implementation, essentially the internet's run on open source with Linux and Apache being at the root. And so I think it's and I guess another example is kind of closer to home in IoT world is MQTT. So the MQTT is a standard that was developed about 12 years ago by IBM and Eurotech. It was developed for oil and gas pipelines monitoring. And so it sat inside IBM and Eurotech for very niche applications until about 2011, early 2012, when IBM said, you know what, this needs to be kind of be more broadly used, and so they decided they would open source it and the implementations of MQTT and take it to Oasis for standardization. And you can see kind of just where they made the announcements that they were going down this and made the code available in open source, that the interest in MQTT started to really take off. So we can just kind of say, okay, well, why is this? Why is openness so important? Why has openness kind of been very successful? And there's a book called The New Kingmakers that really talks about, over the last 5 to 10 years, the importance of developers in making technology decisions. That really, the old model of top-down procurement of technology is no longer valid. That the decision-making, a lot of the decision-making on new technology, especially widely adopted technology, that kind of infrastructure, platform-style technology, is being driven by developers. That the developers are out there learning the technology and understanding how it can be used, and then taking that influence and driving it internally. And so you can't ignore the developers. And kind of one of the things is that's where the innovation comes from. The developers are building the really interesting things, especially in things like the maker community, especially in IoT, with the maker community. A lot of the innovation for IoT is coming from developers in the maker community. So if you can tap into the developers, then you're going to be successful. And the other thing is that if the developers start to adopt your technology, that they will add value to it. And so you get this ecosystem effect that around the technology, and so more and more value is brought into it, right? So you need the openness will start to attract developers. The other thing is that there's been some research around how IoT is going to be successful, and is we need more and more developers working on IoT solutions. This recent report that was brought out by Vision Mobile, where kind of today they estimate about 300,000 IoT developers, and that if we're really going to kick in and hit what all the kind of the measurements look at and research is indicating, we need to get to kind of over 4 million developers. And so how do you do that? How do you start to enable developers? And I think one way that we're seeing is definitely with the rise of open hardware. And it's more like easily accessible hardware. So things like Arduino, Raspberry Pi, BeagleBone are just, it's great for developers to be able to go out and have access to this hardware and then experiment and learn. And so we did a survey of our community, the Eclipse community, and asked people who had been using some of this open hardware. And about a third came back and said they've done something with it, whether they've experimented or actually started to deploy. So that's good news, that people are starting to learn about this. But there's still like 2/3 that haven't been there. And so for the development enablement, I think one of the challenges that in IoT that we have is building a solution is really hard, right? There's a lot of moving parts in the architecture. I think if you're at Michael Koster's presentation earlier this morning, the architecture patterns around IoT solutions are pretty complicated. And this is kind of the typical architecture that we see, where you've got your devices and actuators connecting to some type of gateway. The gateway would connect through a network, whether it's Wi-Fi, satellite, wired internet, and to the back end, right? And so to put a solution together, you need to have hardware experience, you need to have networking experience, you need to have application experience, you need to be able to do gateways. So there's a lot here, right? And what we see is that you need to start thinking about abstracting all this complexity out through through software. And so our goal here is that at Eclipse, what we're looking to do is provide a number of open source building blocks that developers can use instead of having to go out and implement their own version of CoAP or their own version of Lightweight M2M, right? They can reuse it. And that the open source community kind of does the heavy lifting, and so the developers can then focus on the applications on top. And so that's kind of to set the stage. Now what I want to do is go through specifically what we're doing at Eclipse. And the first area that we're doing is providing open source implementations of some common IoT standards. And these standards are really around connecting and managing the devices to think about. So there's 3 main ones that I want to talk about. I'm going to go through a bit more detail. So there's MQTT, CoAP, and Lightweight M2M. So MQTT, I'm not going to kind of do I could spend or others could spend an entire session on MQTT, but at a high level, it's a simple messaging protocol based on a publish subscribe architecture. It's well suited for low latency, very small footprint devices, and it's designed for things like oil and gas monitoring, where there's no power management is incredibly important, and the network is not all that reliable. So within Eclipse, we actually have a number of open source projects that provide MQTT implementations. So PAHO is our client implementations in a number of different languages. On the broker, so MQTT is a client broker, and we have 2 brokers, one written in Java called Noquet, and one written in C called Mosquito. So those are open source implementations that you can come and get and use today. The next standard is CoAP, Constrained Application Protocol, and again, it's how you communicate between the devices and between the devices and the servers. So it's based on a kind of more of a RESTful design point. It works over UDP, and unlike MQTT that doesn't actually have security baked in, CoAP uses DTLS. Within Eclipse, we have a project called California that provides an implementation of CoAP. It's a Java implementation, but it includes the DTLS and a number of the tools to make it easy to build up CoAP applications. Then we have implementations of lightweight M2M. So lightweight M2M is really around device management. It's an OMA standard for really kind of onboarding new devices, registering new devices. It builds on top of CoAP. So there's some integration there. And what we do is we have two projects that provide the client. So Wakaama is the client. It's just a C implementation, C++ implementation. And Leshem, which is a new project that's coming in, is on the server side, implemented in Java. So that's the support for lightweight M2M. And then, so that's on the standards. And then what we do is provide some projects on gateways. So if you recall, kind of the common architecture is you have the devices talking to a gateway, and the gateway is talking to the network in the back end. So at the gateway level, there's a number of kind of basic services that most gateways require. It's kind of like in the early days of the internet, everyone was building their own web server. Because you just needed to build a web server to have a website. But over time, people realized that this is silly, we'll just use Apache. And so we're at this kind of similar stage with gateways today, is everyone's creating similar functionality for their gateways. But over time, I believe that people will start to kind of just reuse open source implementations of these services. So what we have is two projects, Kira and Mahini, that provide gateway services. And again, a lot of these are language-based projects because IoT is going to be very much polyglot. There's going to be different implementations, and so we really believe that you need to have the diversity of languages. So I'm going to focus on Kira a bit, but so Kira is really about kind of managing the gateway. So how do you kind of remotely manage these gateways and keep them up to date? How do you manage the connectivity and the network access? But then also the application that you deploy out to the gateways. How do you keep them up? How do you keep them up to date? How do you configure them? So those types of services. So this is what Kira does, and actually there's a presentation on Kira, I believe tomorrow afternoon around 4 p.m. So Kira is a set of Java services, Java and OSGI services that allow developers who are building IoT gateways to reuse for it. And so it's actually been around. It's based on a code base that was developed by EuroTech a number of years ago, and they've open sourced in the last year within the Eclipse IoT community. So where are we heading with this? We're really getting to where we have this open IoT stack that you can connect and manage the connectivity with the devices, whether it's Java on the endpoint or many different languages, and kind of support for a number of different types of protocols. And then you have the core services frameworks for your gateway. You can run that on different types of hardware, whether it's open hardware or commercial hardware. And then on top, within the Eclipse community, we're also looking at vertical solutions, vertical frameworks for specific applications. So we have a project called Eclipse Smart Home for doing home automation. Again, in the home automation world, you have a lot of different proprietary protocols or protocols. And this kind of state of the art is you download a whole bunch of apps to your mobile phone, and that's your integration of all the different devices in your home. What Eclipse Smart Home aspires to do is provide one framework that all the devices talk to, and you have one app on your phone to control all your devices. Similar idea in the world of industrial automation for doing SCADA systems and for service layers for telco providers. So that's kind of where we're heading to within our IoT community. One of the things where we think at Eclipse is very important is that people build commercial solutions with our software. The success for us is people take the open source projects and embed them into their commercial solutions, and because that's kind of where the resources come back to develop the open source technology too, from a lot of these companies. So we have a growing ecosystem of companies that participate in our community and also use it within their own commercial solution. So to support developers, we have a website called IoT.eclipse.org that really takes developers through all this and provides pointers to the downloads. We actually have Sandbox Servers, so if you want to go out and kind of experiment with CoAP or experiment with MQTT, you can actually write your own client. You don't have to set up your own server. You can use our servers that we have running at Eclipse.org, just to make it easy for developers to learn in this area. We also have a tutorial. It's Java oriented, but a tutorial to kind of take you through to get all this stuff set up and experiment on building IoT. And we actually even recommend what hardware to buy for the tutorial. So that's it. Open to questions. I know it's lunchtime, so but questions? Yes.
So I noticed on the stack, I noticed on the slide that you had of the open IoT stack, you see the industry converging towards that you had reporting over on the side, and kind of didn't really mention it much. I was wondering if you could speak as to the status of like reporting, like
Yeah. So one area, I personally, I think the data in IoT is going to be where a lot of the profit is for companies. And right now, so today we have a project that's called BERT, the BI Reporting Tools Project. And so they are doing some work and kind of making it easy to build reports and visualize the data that you get in through things like an MQTT broker, for instance, or a CoAP server. Long term, I would hope to see more open source down around the analytics and just things like time series databases, too. They're going to be incredibly important in IoT.
Do you see any sort of convergence across the industry towards any common standard or service?
In the data? No, there's not yet. There's a lot of work. Well, there's a lot of people talking about kind of the metadata and actually Michael's doing some really interesting work in the smart objects in terms of defining some of the common data types. But I think we've got a ways to go. Yes.
A lot of the things we focus on the HTTP there, FTTP versus ultra low band, say Quarks, Witness, and any focus on Eclipse and those?
Yeah, so these are more at the application level. So these would work on 6 low band. They want you don't need HTTP. MQTT doesn't work on HTTP. CoAP works on UDP, right? So it's more at the IP layer right now. Yes.
So on the clients, on the endpoints, what kind of resources do they assume are going to be there?
It depends on the client. I think Michael was talking today with CoAP was it 14K for CoAP, or what did you say for CoAP was the client endpoint, the size of the client for a CoAP message?
Oh yeah, it fits in 16 kilobytes of RAM.
Yeah. So
any requirement for Linux, or is it with RTOSes?
Yeah. No, you don't have to have it. It also depends on the language environment that you use it, but you can, a lot of these are available in C, right, in C environments. So yeah.
So suitable for extremely low-end clients with this sort of constraint.
Is it?
Yes.
You mentioned the IoT stack.
Is that the initiative from Eclipse, or is considering the other initiatives around the?
Yeah, we're not providing the IP stack from Eclipse. We're above that, right? So we assume that you've got some type of IP available.
Okay. In terms of interoperability between silos, or in terms of platforms that interconnect those services or those sensors coming from the IoT stack, is there any initiative in Eclipse to consider?
I'm not sure if I understood your question, sorry.
Yeah. For example, in Eclipse, we can see projects that are associated with the IoT, right?
Right.
So is there any initiative that works with the interoperability between different IoT initiatives?
So there is actually a project called, so kind of, how do you bridge, if I understand correctly, how would you start to bridge between protocols? So we do have a project called Ponte, which happens to be Italian for bridge, and it happens to be an Italian that's doing it. So, and so he's looking at how do you bridge between the original problem statement was how do you go from MQTT to CoAP or MQTT to a REST interface. So he's looking at that. It's still not certain if that's the right approach for the industry, but so it's not a done solution.
Just final comment. I'm very surprised that I haven't seen or haven't heard today, this morning, about semantic sensor network ontology, which is the bridge precisely between different data formats for IoT.
Yeah.
So,
Well, and I think that comes back to the original question. Someone asked about the data, right? The formats of the data and the meta information. There's definitely discussions going on. There's actually a new project proposal at Eclipse called Vorto that's started talking about how do you define the metadata of devices and then generate code that can go and help with kind of doing the interoperability. But it's not there.
thank you.
So certainly, if I'll be here, but go and try it out. And if you have any interesting open source projects around IoT, I'd be happy to chat with you about it. Thank you.